families and so the communities in general. So what this company particularly does is employ a bunch of people who have mental disabilities that would normally be at a disadvantage in the world, and they help these people get better placed in the world. So we as a design team, we aspire to help build assistive technologies to help make these people more productive, and therefore they're able to have a steady income from themselves, and the company is able to get enough profit in, that way they can pay for these individuals and help with these programs and so forth. So I'm going to go right in and introduce the team. I'm Rick Schmidt. I am the project manager and the chief product architect.
I'm Dave Antoine. I'm the software extraordinaire or embedded expert.
I'm Captain Callahan, and I will be leading the hardware team and doing all the CAD drafting.
Oh, I'm Captain Smoko, and I'm a member of the hardware team.
And I'm Kate, and I'm specializing in hardware as well.
Great. Jumping right in. So we're going to start off with the needs and the actual objective of this project. So when LifeSpire approached us, they basically had a particular use scenario in mind, and this was a technology that was built upon for the last couple of years. So what we really wanted to do is build an assistive technology to help disabled workers become more productive at what they do. So one of these particular jobs is filling large orders. So this particular setting is in a warehouse setting, and some clientele such as the New York State Housing Authority will place multiple million-dollar orders, and they have these huge orders to fill these products with. So these individuals will actually go through the order and actually fill up bins and so forth to make sure they have the right orders and they're shipping those out to the right things. So as you can imagine, since these people, the people that we're probably working with, the main users of the system, are probably around half of the mental capacity of what a normal person is. This could be toothbrushes and toiletries and so forth. But you also go all the way up to this larger scale environment where it's an entire warehouse. This looks like the Home Depot, really. So this product, while initially we're starting with smaller scale things, the client aspires to scale eventually this technology to a larger use case, which is to actually get here. So I'd like to invite Katie up here to introduce
the system as a whole. So you would have your worker looking at the shelves, all the boxes, and they would light up and interact with the system that way. We also showed a side view of what our system would be, being that there would be managers in the back kind of stacking the boxes from one side, so they would slide through to the other, and then the workers would be on the other side interacting with it and filling the orders. So for the hardware elements, there were 4 main elements. We decided to have an LED controller, a shelf controller, central control, and a wireless hand scanner. For software, there will be a database developed, a QuickBooks add-on to go with their already existing inventory. There will be systems in place in the central controller and the shelf controller as well. So for a picture of it, we would have the wireless hand scanner interacting with the central controller, and then the computer and the central controller both interact with the database that will keep track of SKU numbers and orders and history and all that, so they can do audits eventually. And it'll all be done through some form of wireless communication.
Has a very specific target and a very specific customer, so the market is kind of limited, but it's definitely expandable, because though this product is designed for people that are mentally handicapped, it could definitely just as easily be used for the average person, and it could still increase their productivity and their efficiency. So the market is definitely expandable. So our competition, then, there's not really a product like this out there right now besides the previous 2 years attempt at this project. So our competition is really with Manhattan College itself and the previous years. So I'm gonna use the previous years as our competition. So these are some kind of improvements that we're going to make upon the previous year's projects. In previous years they built the shelving units themselves. We found this to kind of hinder the design of the project because, one, it kind of limits the scalability and versatility when you're designing for a specific shelving unit, and additionally it takes up our time and our money that we feel could be put to better use. So that's one improvement we plan on making. Additionally, we plan on finding an alternative to using RFID scanning. So as it existed in the last couple of years, when a product was taken off the shelf, they would use an RFID tag and scan that to know that a product was taken off the shelf. But we found that this might not really work with small scale items because the RFID scanner has a fairly wide range. So if you have close RFID tags, there would be interference from other tags. So we're looking into alternatives like barcodes or QR codes, which are cheap and easy. Like the customer could make them on site. They have the software to do it, so it'd be easy for them. Also, we plan on using a lot of off-the-shelf components in our design, which will definitely help the customer because they're easily accessible and they're inexpensive and there's a lot of options. Like for example, we plan on using Ethernet cable to connect the LED controllers. You can get Ethernet anywhere at any length and almost everyone knows how to use it. So the customer could easily get someone to, like a contractor, if they want to increase the amount of shelves they have to just connect it up with Ethernet. Finally, we plan on making the desktop software so that it is incorporated with their current QuickBooks program that is used for their inventory and invoicing as it exists now.
So Katie touched on it already about the existing projects that were the first year and the second year at Manhattan College. So again, the first year they had they had stationary RFID tag scanner. So they planned to have RFID tags on every single piece of clothing put on by manufacturers, which didn't really end up being feasible. So the second year they decided to have just the tag on each individual box. But like Edie said, when you go to scan it, there could be interference from the surrounding boxes, so kind of an issue. Also in the first year, they used white LEDs for each box, so that would only allow one user really to use the system at a time. So the second year, they tried to expand upon that and use RGB LED strips so that they could be programmed to be basically any color you can think of. They were just using red, green, and blue so that they're very distinguishable and noticeable. The issue with that came with all the wiring. There was 4 wires per strip and 25 boxes, and wiring them all to a proto board and then like it's just wires everywhere. So that's what we're proposing to use. Ethernet, so it's just one single cable. There's not a lot of wiring. It's easy to implement and construct. A big issue from the past 2 years was scalability. You couldn't really implement their whole design onto a warehouse scheme due to all wiring issues.
A big shelf or a medium shelf or something like that. The system also needs to be going to use. The system needs simple controllers. So the system needs to be easy for the user to use and simple to operate. The system also needs to also adapt to multiple users. So you can have multiple users, as I said before, like maybe 5 to 10 users at a time operating on the system. The system also needs to adapt to the different sizes of the inventory that the company has. So the system needs to be able to adapt to like the smaller size or bigger size of inventory that they have. The system also needs to be easy to integrate, so the system can adapt to the different workflow that the company currently has. The system also needs to be portable. So again, you're not dealing with a lot of wiring. The system can be easily moved, or in case something goes wrong with a component, you can easily take it out and replace it there.
So, okay, so the project summary. This is a whole lot of words, so I'm just gonna try and briefly explain what I have written here. So basically what I have is just an example. You guys probably get the gist by now, so it's a little redundant, but I just came up with an example. Say a user is assigned, like one of the employees there is assigned the color red that day. The supervisor comes and says, you're going to be scanning red items today and boxing red items. So they go, okay. And then say an order comes in that needs, you know, a men's large shirt, men's medium pants, and a large men's jacket. And say that order is also assigned the color red. So the shelf containing those boxes is going to light the boxes up red. So that employee knows, oh, red's my color. I need something from that box, I need something from that box, and I need something from that box. So they'll go over to one of the boxes and they'll take out the large men's shirt, and then they're going to use their hand scanner to scan the shelf, and since they only needed one, the light's going to go out saying, okay, good, you got this item, on to the next item. So that they know, okay, well, I grabbed that, I still have 2 things left to put in this box before the order's complete. So it's a lot, they can visually see what they've done and what they needed to do before the order is complete. So that's, like I said, you guys probably have gotten that.
Minimal words or anything like that. And I think with the mentally handicapped, the effective communication is very important with them. And the system must be scalable to either size, and that the size of the warehouse should be arbitrary to the functionality of the system, and it should be able to be applied into a room that's small or even as big as a warehouse. And the system needs to be easily deployed and assembled. So we're just designing the electronics. Like we were saying before, we didn't want to design the boxes because that would just be a waste of time, money, and energy going into that. And we're also not mechanical, so that's not even our concern. And plus, working on only the electronics means we could apply it to any of the shelves they have instead of remaking it ourselves. And using the cascading method allows it to connect really easily to different size shelves without having to create more and more wires. We could just make the daisy chain a little longer just to achieve one more